Okay, we're going to prove some segments or portions of segments being congruent. And in order for us to do that, we need a postulate that's going to help us with this. And this is called the segment addition postulate. What the segment addition postulate says is that if I have 3 points on a line, okay, in this case I have A, B, and C on a line, then I know that each little part added together is going to equal the whole thing. In other words, this portion right here and this portion added together should equal the entire thing of AC. We're going to write that though as AB plus BC equals AC. We've done this in terms of numbers way back in chapter 1. Now we're going to do it in terms of actual proofs. Okay, so there won't be any numbers. We're going to continue looking at 2-column proofs to help us prove segments being congruent. So, an example. Okay, I've already started the table. I put down my 2 columns, statements and reasons, and I put what was given in there. CE is congruent to FE, and I know ED is congruent to EG. And they've got the picture right over here for us. Okay, that's what we're going off of. We're trying to prove that the big segment CD, so this segment, this whole thing here, that segment is congruent to this segment FG. Well, if we look at it, they look to be equal, but we're trying to actually prove that they are equal. Okay? Your first thing that we're going to want to do here, okay, is we can't work with congruence very well. So we're going to change our given, and we're going to change those to equals. It's a very easy step for us because we know we can convert between congruence and equals. So step 2, I'm going to say that segment CE is equal to segment FE, and I'm going to say that segment ED is equal to segment EG. I can say that because I know by the definition of congruence. So definition of congruence. Okay, that's my reason. Next, we're going to go on to statement 3. This is where it gets a little bit tricky because the given doesn't give us a whole lot. The given does not give us that much to work off of. All I know is that each little portion. So I know from my given that CE is equal to FE, and I know that this is equal to that. Okay? I know that. We're actually going to use that postulate on the previous page to help us get some more information down on our proof. Okay? And we're going to use that postulate twice. If we use it, say, on CD first. Okay, let's use that segment addition postulate on segment CD. So I'm going to erase my marks up here again. I want to use that with this segment right here. Okay, if I want to use that postulate, then I know that segment CE plus segment ED should equal the whole thing. Okay, so let me write that down for us. Segment CE plus ED is going to equal CD. Okay? And that we know is by the segment addition postulate. Let me write that down and then I'll go back up and show what actually happened up there. So segment addition postulate. Shorthand that a little bit. All I did from my picture was I took that this little portion plus this portion should have equaled the entire segment. That's what that segment addition postulate says. Okay? That's all I did there. Now I want to manipulate that statement 3 in my next portion. So I'm going to keep it right there. Okay? I'm going to actually mark that I've used step 1 completely. I've done something with it, so I'm going to put a star next to it, saying that I'm done with it. Okay, I want to use statements 2 and 3 at this point. Okay, and if I look, I see a CE here, and I see a CE here. CE is actually equal to FE, so I'm going to put that in. Okay, I'm going to replace CE with FE in statement 4. So I've got that situation. Plus, you can see the same thing, ED, and here's an ED. ED we know is equal to EG. So I'm going to replace that as well. But both of that added together should still equal CD. Okay, that's not going to change. That side's not going to change at all. The only side that I'm changing is the left side of that. And I can do that by the substitution property. Substitution allows me to substitute equal things in. So substitution. Okay, that's my statement 4. So now I technically use statement 2 and I've used statement 3. I want to go back and I want to use the segment addition postulate again. Okay? Because I technically have 2 segments up there. I've really only done it for 1 segment. So I want to use the segment addition postulate again. And that will probably help us figure out another step after that. So now I want to use the segment addition postulate on FG here. So I know that FE plus EG should equal the whole thing, FG. So that's what I want to put. We're going to put FE, let me get a different color here. FE plus EG is going to equal FG. And again, that's the same reason as number 3 from above, the segment addition postulate. Okay? We'll go on to number 6. I don't need the picture to come up with number 6. If we look at statements 4 and 5, okay, because I've used all the other ones, I've used 1, 2, and 3 to come up with other statements. Now I want to use numbers 4 and 5. Well, if we look, FE plus EG is right there, and FE plus EG is right there. But they're both equal to different things. Well, based on that, we know then that the right side, CD, is equal to FG. We can state that now because these 2 sides right here are the same. So let's state that in number 6. CD is equal to FG. And all we did here was perform substitution. I'm substituting in, you can think of substituting this CD in for this side, if you would like. Or vice versa. You could say it the other way is fine too. It doesn't matter. However you want to think about it. Okay, then number 7, we're almost there. I'm going to go back up to what we were actually trying to prove so we can see that we're pretty close. I was trying to prove that CD is congruent to FG. And right now I have CD equals FG. So we're going to change that back to congruence and then we got it. CD, segment CD is congruent to FG. And what allows me to actually do that is by the definition of congruence again. That allows me to change between equals and congruence. And there's your proof. You finished it.